All right, so it says, which statements are true about the graph of f? And f of x is log of x. So let's just graph the log of x and see what we get. All right, so we'll go in here, clear this out. I'm just going to do log of x, graph it. So that's the log of x. Nothing too fancy. But what we're going to focus on are statements about the domain and the range. So if I look at that graph, there's two things that I notice about the domain and range. And those two things are what it's basically the end behavior, the domain and the range, and then the behavior. So let me just paste. I'm going to just literally just copy and paste. So the graph has a domain from 0 to infinity. So my domain is my x direction, right? So it starts here at 0, and then as we go left to right, it goes on forever to infinity, okay? So that's the domain. Remember, the domain is focusing on the x, and it approaches 0 as x decreases. So as we go this way,
Varsity track to the high school gym, please. Varsity track.
Sorry, I heard the little click. So now it does approach 0, but there's this, I don't know if I agree with the statement. So this is what the online book says. It approaches 0, but really it kind of approaches, if you look at let's look at the table of values. So this is the answer according to the online book, but I mean, as x decreases, it does, let's just look at this. This is what I hate about textbooks sometimes. As x approaches 0, you get an error, okay? So, and we'll talk about that, but if you look at the graph, there's this big chunk between 1 and 0. So clearly when x equals 1, it's at 0. So if I were to change the, if I start at 0 and I do a table of like 0.1, whoops, 0.1, and now I look at the table of values, I get some negative values in there, okay? Those are, we'll talk about that later. But as you can see, this is sort of true, but I don't like the ambiguity of it, right? Like, it's saying as x decreases. So as we go this way, it does approach 0 and it equals 0 here. But as you continue to decrease, there are some issues. Now, y, it says the range. Am I reading this question right? Y goes from negative infinity to positive infinity. Let me think that through. And decreases as x approaches 0. Well, this part is true for sure. It decreases as x approaches 0. But what they're saying is that y goes all the way to negative infinity. Now, I know the answer to this, but I'm trying to present this like I'm a student, how a student would think. So when you look at this graph, it's kind of hard to tell from the graph, but can I make this a really big negative number? And one way to find out is to get very close to zero, because obviously at zero, we can't take the log of zero. We just can't. There's no way to do that. Doesn't help anybody. So what we're going to do is we're going to go back and set up our table. And I'm going to do this. I'm going to say 0.0001. And we're going to start at 0. So now when I look at the table of values, I should have a very negative number. So it's there, right? We can't see that on the graph, but it's there. Okay. So what happens if I put some more decimals in there? So if I go 0.0000000001 and then I hit the table of values, what will I get? Yeah, negative 13. So as I get really, really close to zero, this is going to start to approach negative infinity. And that's it. So that part's true. The only thing that I'm struggling with a little bit is it says as x decreases, it approaches zero up to this point. So they're saying as x decreases, and I think what they're saying is as you go this way, it approaches zero. But as we can see, the range goes all the way down to negative infinity. It's kind of hard to tell on the graph, but it does. In fact, we could even zoom in on the graph. If I, let's adjust the graph so you can actually see it. So if I go to, well, we'll just hit window. If I let my x equal 0, and we'll put this at point, well, we'll put it at 1. And then we will, our x scale will do 10. No, we'll do 0.1. And our y minimum, we will put at 1. No, negative 20. And we will put that at 1. And we'll make our scale 0.1. And then let's graph this. So it's kind of hard to see. You really got to zoom in. So if I go 0.1, and now I graph it, it's still kind of hard to see. So this is like 0.1. I'm really trying to get the graph, but it's hard to see. Anyways, that's the answer.